边线的是吧？
对，
民黄
旭，
哎，我在找那个 SK Telecom。对，是吗？哪一个？第一个是。First speaker?
Yeah.
Oh, okay. No, we're looking for you. Okay, right. So you're here, right? Okay, just be prepared. I will call your name. So, Sonny? Sorry. Yes, we are ready. You ready? He's here. 在那里。Okay, good afternoon. My name is Akeno Huang. Welcome to join the IPv6 deployment section. And today we're going to introduce a lot of IPv6 deployment section status, and especially what happened in different carrier, different ISP, and different countries. So let's welcome the first speaker, Yong-Woon Lim from SK Telecom, to give us the introduction on IPv6 deployment and challenges in SKT 4G and 5G. Thank you.
Hello, good to see you everyone. I'm Han-Ung Lim in SK Telecom. Today I want to share my experience with you, IP version 6 deployment and challenges in SKT 4G 5G. As far as I know, this topic has been addressed already in APNIC, but after many years, I can share more new experience with about changes and 5G readiness. So let's begin with backgrounds. I have to say one thing first. My company is not South Korea Telecom. SK is just SK, no abbreviation. In fact, yes, there is Korea Telecom in Korea, but there is no North Korea Telecom or South Korea Telecom. So please don't misunderstand SKT as South Korea Telecom. I hope it's a good thing to get to know you two from this seminar. We have 30 million subscribers, and South Korea population is about 50 millions, and LTE subscribers exceeds 20 million as shown in the graph. The average data utilization per subscriber is about 6G per month. We are also doing a lot of service activities in telco and service area. In MNO area, the launch of 5G frequency was completed in December last year. We are doing IPTV, OTT, and music in the media sector, and we're promoting home and smart city IoT in the IoT area. In addition, AI platform business also published for AI security service. With so many of these subscribers and services, the biggest reason for adopting IP version 6 is the depletion of IP address. Especially LTE and 5G terminals can have 2 or more IPs using bearers. Limited IP version 4 address would quickly run out of our resources. So it's forcing us IP version 6 to be introduced. So we decided to adopt IP version 6 with 4 reasons. The IP address depletion problem I just told about, and the IoT terminals might need. There is also needs from national level for the pride of Korea as an internet advanced country. And the last, we need to prepare new business model or new service. the result of difference between before and after IP version 6 implementation may not be significantly changed, because the problem that I mentioned was not exposed to the outside world, but it was definitely to have to be solved in our company inside. So it also brought us to change not only internally, but also other companies, especially the hegemony of leadership between mobile operator was so important. So this led to change in IP version 6 in Korea. So it's very much similar to when we before changing 3-digit country code to 4-digit country code. It does not much open to public, but it's changed a lot. So let me tell you about the use of IP version 6 in SKT now on. We are actually using IP version 6 for all LTE subscribers. Some of network operators don't use IP version 6 much, in fact, but we do. So we are now handling the biggest IP version 6 traffic in Korea, approximately 60%. Also, we high ranked in the global IP version 6 usage. The IP version 6 user number is much more than mentioned below. I don't know why it's underestimated. If anyone knows about the measurement logic, please let me know after session. So to make it accurate. So this is our IP version 6 status quo. From now on, let's look how mobile IP version 6 network is organized. The LTE network is consists of access and core network. The P gateway is the function that assigns IP version 6 address to user's device in the mobile network. After going through the base station and core network, it will reach P gateway, and it enables actual IP basis service to the device. After device goes through the IP allocation process, a pure IP version 6 communication with outside internet is possible. But in reality, services outside internet and some CPs don't accept IP version 6. They still maintain IP version 4. So we use standard technology, RFC 464 XLAT, to ensure 100% service, even in such situations. The basic concept of 464 XLAT is according to the destination address, it will communicate with whether IP version 4. Yes? Sorry. Okay. Thank you. So we use a standard technology RFC 464 XLAT. So it will communicate with correspondingly whether IP version 4 or whether IP version 6. For this, CRAT technology on the user's device, DNS64 and NAT64 technology on the provider side, which is PRAT. CRAT is the client-side source IP version 6 NAT performed by device. And DNS64 adds a special 64 prefix when returning DNS response, and it enables a conversion IP version 6 to IP version 4 on NAT64. So they work together. These 464 XLR technologies have evolved over the years and are currently being deployed by many MNOs, such as these operators. This IP version 6 network structure has scalability to service massive mobile users. For instance, this EPC plus XLAT structure could be created by X numbers of in-site and distributed as many sites as Y. So we are operating network like this, but looking back on years of experience, there are some need to be improved. Since P-Gateway is the mobility anchor point and NAT must manage the session to support TCP-based internet characteristic. In other words, packets will be dropped if traffic enters a device that has no session. So P gateway and NOT should be worked in pairs and dedicated. And not all NOT and firewalls does not support exact architecture. So additional standby backup is also needed. So in this structure, we can't use 100% of our resources for service. Resources being dedicated, not flexible. Even some devices can handle more traffic, but we can't because of this dedicated bottleneck. Of course, depending on network structure, some problems can be solved, but we think it's a trade-off between reliability and efficiency. So first challenge is that requiring dedicated resources and backups. This situation is one of reasons why in 5G there's flexible resource planning and cloud-native core. And second, the network complexity grows continuously. There are some static and unique settings for inline middle box devices, such as NOT L7 layers devices. In other words, we need to manage IP pool using static routing and PBRs, such as like that. If any of these errors or bugs or mistakes occurs, there has been a national communication failure, so it's very critical to our KPI. So it requires very sensitive work to manage the network. Of course, we are also working on this problem through SDN and automation, but I think so far these are not fully supported or yet can handle complex job. And furthermore, there is no site level or domain level control, which means we can't dynamically managing IP resources across the network. So in conclusion, these engineering issue, management difficulties are our challenges. So now let's talk about IP transition process. There are 4 factors that make IP version 6 service possible in the mobile network: user device, network, telco system, and internet service. The network and telco system have been made by SKT itself. Devices and internet service verifications were made through the cooperation with other players. Let's look into the user devices in detail. The first device that support IP version 6 started in 2015 with Samsung Galaxy Note 4. This Android device supports pure IP version 6 with even if hard-coded IP version 4 apps can even support through CRAT. From the launch process of the device, it has been verified to provide the same level of service as IP version 4. For now, devices released by SKT supports IP version 6 only and also have cooperate system with other manufacturers. The second is the IP network system. There are 3 areas related: backbone, LTE core network system, and IX network. The first, IP version 6 dual stack is applied to backbone network. Most of big routers had no problem with supporting IP version 6. 6.4 XLAT was applied to LTE core as previously stated. The next is IP version 6 peering with first-tier ISP providers. They are connected with foreign CPs who's offering IP version 6 service, Facebook, Google, so on. And finally, the internal services that are connected with IP version 6, this includes App Store, IoT, and LBS services. The third is the telco system. The LTE EPS systems require development of each IP version 6 function. So we developed about 40 system functions to provide LTE IP version 6 service. The most difficult thing is that each of systems are multi-vendor basis, so systems needed to be developed separately. This took a long amount of time, and servers IP version 6 performance issue was also a problem. Next, internet service validation. In order to provide the same level internet service experience, we verified over 1,500 different apps in Google Play Store, and errors in the verification process have been corrected before IP version 6 launched and after the launch to ensure the same service experience. So finally, I'm going to wrap up the impact of these activities and conclusions. I want to explain the differences that SKT IP version 6 has. It's pure IP version 6, which means we provide end-to-end service only through IP version 6. In a network perspective, pure IP version 6 resolved the problem that depletion of IP truly. The dual stack network in typical broadband service will not solve the problem. They still need IP version 6 also. From the service perspective, both data and voice services are provided by IP version 6. So each LTE PDNs have IP version 6 address only. And from a collaboration perspective, we have collaborated with other players to ensure internet services work well on IP version 6 based. So all these IP version 6 things were not just for lack of IP address, but also scalability, sustainability, and future preparedness. For especially in 5G, the IP version 6 will expand with the IoT, SRv6 based network, and edge computing like MECs. But there are some realistic constraints too. For instance, IP version 6 is too heavy for thin clients like some IoT devices, and additional development and bad performance is very frustrating. And many customers and CPs don't care about IP. They just don't feel about any advantage for IP version 6. Anyway, the reason why SK Telecom did IP version 6 was because we thought about our worst case and we knew we can't hide from the problem forever. So embracing IP version 6 was the best choice to our company. So we did it. Thank you. If you have any question, I would appreciate it.
Question?
Yeah, Jordi Palet. In your last slide, you mentioned that it's too heavy for thin devices. I am really surprised about that, because having a dual stack versus just IPv4, typically it means only between 5 and 10% extra code. So I don't really get from where you have that conclusion.
You mean our IP version 6 too heavy things?
You say
Yes.
in the number 4 practical conclusions, IPv6 stack is too heavy for a thin client.
In our case, some of IoT devices have no IP. They use MQTT protocol.
Okay,
Yeah.
okay. But then it's not about the IPv6 stack, it's about IP.
Yes.
Okay, okay. Now I understand that. The other thing is, in several slides, and this is more an observation than a question, but I think this is very important for the community. In several slides, you mention 6-to-4 translation. I think that's a trouble, because what you want to mean is not 64 translation. 6-to-4 is a different protocol. So if somebody is looking at the slides, not looking at your video, at the video of this session, can get confused. The same that in some slides you mention, instead of 464 XLAT, 64 XLAT, which don't exist. So this is a plea. Use the good terminology because we confuse the people that we are trying to train. And if they get trained with mistakes, that's a trouble. Thank you.
Thank you very much. Okay.
Frank Martin from LinkedIn. So you talk about 624 translation or not 64. One thing that is useful, and I'm not sure if you have got the data, what are the biggest sites or category of site that you're obliged to do 624 translation? That would be very interesting because if the site are on 6.6, you don't need to do an XLAT or not 6.4 translation. So what are your top categories of site that should be on IPv6 today to reduce the pressure on doing this translation?
I don't get it. Can you speak more easily? Sorry.
It's my French accent, so let me try my American accent. No, just kidding. We've seen that on the IPv6 community, we've seen that the providers that are doing mobile IPv6 only network need to do a translation to reach the IPv4 part. Therefore, your device that does the 624 could be lighter if they don't have to do it. So where is the low-hanging fruit? Which site you would like to see with an IPv6 address so you don't have to do this translation? What do you see on your network?
The main reason we choose 64 XLAT is we don't have much public IP address. So we have to manage the IP pool with...
No, I'm not asking you why you do it. What destination are still on IPv4 that you would like to have on IPv6?
There are many local sites as games or...
So it would be useful if you could give us this list.
For instance?
Well, if you could publish this list, it would be really useful to know what are the big area of the internet that you see that is V4. Because it helps people prioritize, which site should be converted to V6.
Maybe I can help you. Sanjaya from APNIC.
Okay.
If you said that, and I know that in Korea, gaming is really popular and there are lots of bandwidth consumed by the gaming industry. So is it hard for you to talk to the gaming provider for them to move to IPv6? Have you spoken to the gaming provider to move to IPv6?
That might be a not good example of when it comes to in mind. There are so many IP version 4 sites, not especially games. Both Frank and Sanjaya.
Yes.
You can give me email so I can give you a correct answer.
Yes, I think we'll be interested in the content provider that we could talk to them and say, hey, you need to move to V6.
Well,
we will help. We will help.
If you have a priority list, we can help.
Okay, thank you. So the next speaker will be Akeno Iwamura-san from JiaBin. He is going to introduce the initiative for IPv6-based network in Japan. Thank you.
Thank you very much, Kenny. My name is Akeno Iwamura from JAPNIC. Yes, I am now introducing the new, brand new named activity in Japan. I think you know about Task Force for IPv4 Address Exhaustion Japan. It's been quite a while to do some promotion work, but it's a Task Force for IPv4 Address Exhaustion is contactable from this URL kokatsu.jp. And if you had the sense of the Han character, Kokatsu is an exhaustion, then kokatsu.jp still exists. But it was founded in 2008, and then we have the 20 internet associations plus government, and then we thinking about we were considering about how to adapt IPv6 before IPv4 address would exhaust. But then we have had a lot of activity until 2011 when the IPv4 address at RIL level depleted. We developed the suggested action plan and the milestones for the multiple segments. And then we did a lot of outreach and engagement activity for the IPv4 address exhaustion. And after the exhaustion, we had less activity than we had, but sustained. For example, the task force maintained the periodical meeting like a monthly, and then we are still having that in bi-monthly. So we were doing the follow-up of the suggested action plan and milestone, and then we have some further activity like access network sub working group has been really active to maintain that activity. For example, right now, thanks to the effort by the access network working group, now Japan has the more than 50% of the deployment of the IPv6 for the fixed network, and then we have the 25% plus IPv6 deployment in the mobile network. It is a really rapid curve. That's thanks to the effort by that access network working group. Then 2018 still there, but we came to the question: is it still for the IPv4 address exhaustion? It's far before the IPv4 address was exhausted. Then we were thinking about what is the next. Then now we came to the conclusion to evolve the Kokatsu task force for the next needs. So by rechartering it to fit the new needs, and then rename it to clarify its mission, and then we actually enjoy the 20 members from the various industry association. Then that's really exhaustive list of the associations pertaining to the internet. So we retain that membership to do something new. So now I'd like to introduce you IPv6 initiative for IPv6 based internet, which was the renamed version of the Kokatsu task force. So then it is just born, and then we are now creating its website, and then the domain name is just registered i6i.jp. It is being deployed, but not now. Then it is for the English name, but we have the Japanese name, which is with like this: IPv6 Shakai Jitsu Suishin Task Force. That's the hand character says, and then translation for that is Task Force for Promoting the Social Implementation of IPv6. So these two naming are meaning something the same. That the social implementation, meaning not only the technical deployment of the IPv6, but deliver the IPv6 access to the society, aiming to have that in the very infrastructure of the society for the next generation. Then for that purpose, we chartered the Kokatsu Task Force into the initiative. So we had the target. So IPv6, IPv6 based internet to be realized in 2025. That's maybe the ambitious the target, but we envision this target for the additional activity to promote the IPv6. Then we are going to do the coordination of the information sharing and then information about the design and operation of the infrastructure for the IPv6 based internet. And then why we need to have the IPv6 only based on the internet, because we need to reduce the cost and burden by the having IPv4 as well. So that's we try again to research something for providing the information to the community, and then educate the network operators to apply this scenario. Then to examine and share whether the businesses, services, and applications which are currently available on the internet can migrate into the forthcoming IPv6-based business environment, cooperating with the various stakeholders. So throughout the Kokatsu Task Force activity, finally the access network, the readiness for the IPv6 on the access network is really fairly high, like more than half at the fixed network, and then more than quarter in the mobile network. And then mobile network IPv6 adoption is uptaking right now. But what we need is that the society based on the IPv6 internet. So it is a little bit, again, it's ambitious, the concept, but it's a really good challenge for us to, again, take effort to do that kind of the new infrastructure for the society. So IPv6, Kokatsu Task Force has the, why we don't have the slide here? Here, there, okay. The bottom is the Kokatsu Task Force logo, and then we are now evolving into the initiative for the IPv6 based internet, and then we have the 20 membership. As you see, a logo in the both sides. So this collective action will be changing anything for the internet. So that's our belief, and then we will take an effort. Thank you very much.
Any question?
Any question?
No question. Thank you.
Okay, thank you.
So the next speaker is Min Hong Shi from Chunghwa Telecom. He's going to introduce IPv6 deployment in Chunghwa Telecom. Thank you.
Okay. Good evening, ladies and gentlemen. I would like to talk about the Chunghwa Telecom IPv6 deployment, and it's our slide. Okay. This presentation will focus on 3 parts. The part 1, we are talking about the status and trend of IPv6 in Taiwan. And the second part, we are talking about the IPv6 deployment in Chunghwa Telecom, and including fixed network, mobile, and R&D department. The final, we are talking about issues and the results we have made this year. Okay, the first part, we're talking about the status and trend of IPv6 in Taiwan. As we can see from this chart, the ranking of Taiwan's IPv6 global ranking is from 67 to number 8, within 1 year. And we can see the Chunghwa Telecom has 2 events to push the usage increase dramatically. The first is in February, we launched the 4G commercial service, and in August, we launched the fixed network HiNet. commercial IPv6 service. Okay. With these two promotions, let's take into the rank of ISP in Taiwan. We can see the Chunghwa Telecom mobile and the fixed network department has located in the first and fourth place respectively. And with this promotion, I will go into next topic is IPv6 deployment, and we are talking about the fixed network, mobile, and R&D department. Let's look into the milestone in Chunghwa Telecom from 2011 to 2019. And Chunghwa Telecom participated in World IPv6 Day in 2011, and HiNet launched dual stack trial service in the same year. And in 2012, we participated in World IPv6 launch, and we not only support IDT Center, but also support the GSM Network project in 2013. And in 2014, HiNet Online e-service provided IPv6 application. And in 2017, HiNet expanded the scope from the fixed network to mobile and public wireless LAN. And in 2018, we launched the commercial IPv6 service in fixed network and 4G mobile network. And in this year, we still have launched the commercial IPv6 in public wireless LAN. Okay. How to make the milestone happen? We need to define some evaluation list from the CP side to customer support. We need to check the seamless handover problem from CP side, and we need to guarantee the network performance and security in network side. We also need to verify the OSS BSS availability and reliability. Finally, we need to pass the government approval law for interception approval and to meet customer certification. But how to pass the evaluation? We need to break down into some item like this slide show. From right side, we can see we need to do some software upgrade, and we need to fix the AAA record. We need to fix the OSS BSS information system and do some training for staff, and we need to do some things about the service website to do some description about IPv6 promotion. Okay, with this preparation, we focus on 3 topics. The first one is fixed network, and then is mobile, and the final is public wireless LAN. And we launched the trial service in 2017, and expansion the trial service to the scope to 2018, and we launched the commercial IPv6 service in 2018. We still want to launch the Wi-Fi commercial IPv6 this year. Let's take a look, take the HiNet as an example. We know that IPv6 end-to-end connection requires support from UE network and content. And in network, we support IPv6 about 100%. The main issue, the key issue is the home gateway need to upgrade both. And the home gateway need to upgrade support for IPv6 is the key issue. After finishing this preparation, we can show this chart. The HiNet IPv6 capability is from 4.73% to 20.74% within 1 year. The next slide, we also take a look at mobile network IPv6. It's also the same key issue is the UE problem. The UE default need to enable IPv6, and it need to coordinate by the manufacturer. So let's take into this chart to see the mobile network IPv6 capability matrix. And we show the capability is from 1.61% to 75.45% within 1 year. Okay, behind this promotion, the R&D department played a very important role in our company. The R&D department established the IP video ready logo accreditable rate in Taiwan, and the test capability include IPv6 core, IPsec, DHCP-v6, and the CE router. But all are some the manufacturer have passed the IPv6 ready logo. like Lideo, D-Link, and Acton, etc. The IPv6 ready logo or certification can see this chart. Taiwan is located in the third place and account for about 17.4%. Okay, finally, we're talking about the issue we have made and the results this year. The first issue is the content issue. Some IPv6 content will be served via international link. It may cause an increase in delay. And we can see next page. We know that quality of experience is very important for us. So we monitor the user experience of the top 100 websites from the data. We need to guarantee the time difference of opening a web page within less than 1 second amongst 90% tests. And the second issue is CP-MTU issue. The CP device MTU have default setting. If the website object does not support TMTU, it may affect the response time. So according to this page, to show that if the response time will increase to 6 seconds if the MTU of CPE is inconsistent with the website. The final issue is 3G SGSN issue. 3G SGSN software need to upgrade to resolve the IoT issue between SGSN and MME. We know that the 4G user, when you move to 3G and back to 4G, it may have problem to get before website. So we need to some SGSN software upgrade. This final issue. Okay, the result. Zhonghua Telecom held IPv6 press conference on September 13 last year. And then we keep improving Taiwan IPv6 ranking of the world. In the future, we will cooperate with CP industry and the content provider to provide IPv6 and the IPv6-based network. We expect it to continue to be a Taiwan leading ISP in IPv6 to promote development of 5G and IoT industry. Thanks for the listen.
Okay, thank you. Any question for Zhonghua Telecom? Okay, Jody.
Jordi Polet. I am understanding that in both your cellular and wired networks, you are using only dual stack?
Dual stack.
Dual stack. That means that you have in the country, let's say in the country, not by ISP, because I understand that Zhonghua Telecom is the bigger one, but in general in the country, do you think enough IPv4 addresses allocated right now by APNIC and for the next, let's say, 2 or 3 years, or you expect to change your deployment model in the future?
We expect to change.
Okay, so you expect to change. Okay.
Right.
The other question is, I am not sure to understand the problem of the MTU. I guess you mean path MTU discovery. But if you have that problem, the operating systems, at least the browsers, have the happy eyeballs mechanism. And I don't think it can be so huge difference between 3 and 6 seconds, because then it will drop to IPv4. So I am not really sure to understand what is going there. We can talk it offline, but I think I am missing something there to understand the situation.
I know that the main problem is the CPE side. You need to support the MTU to change to not to set the default setting. And if you want to the detail, I need to check our technical person.
We can change some emails. Thank you.
Yeah, you can discuss offline because Zhonghua Telecom has a customer service somewhere downstairs. Okay, Sanjaya.
Sanjaya from APNIC. Just curious, when you're deploying 5G, I know you're planning to deploy 5G. Do you think you'll still be doing native V6, or would you still use V4 as well?
I know that V6 is in our 5G plan, but detail I need to check it.
Okay, thank you.
Sorry.
Okay, right, thank you. Okay, next speaker will be Tash Fangso from APNIC. He's going to introduce, let me check your title. Sorry. Oh, he's going to introduce Fixing IPv6 Issue, a User Story. Hopefully I'm right. Thank you.
Good evening, everyone. I'm Tashi from APNIC. Everyone spoke from an angle of them running their network and deploying it in their network. Mine is more as a user of V6 in someone's network where I noticed a problem, reported it to them, and then they worked on fixing it. So, I was in Bhutan for BT NOC, and that's when they actually started doing V6 deployment in their mobile. And before we left BT NOC, there were not many users on the network, but around September, they had about 12% IPv6 capability for the whole country. But I was again asked by the SANOC PC, because there was the South Asian Network Operators Group Conference in January in Bhutan. And the PC asked if we can give a V6 update for the region as well as Bhutan specifically. So while I was looking that up, so as you can see, this is somewhere around 8th of December. And the SANOC conference was supposed to happen in January. When I started looking, since November, actually, their capability, Bhutan's capability had dropped drastically, right? It was close to 12%. It has come down to just about 5% capability. And few of my colleagues within the program committee, they started asking me if, since this is APNIC's measurement tool, if we could try and explain why this sudden drop. But the measurement tool can only measure what it sees. So luckily I worked for Bhutan Telecom before I joined APNIC, so I still have my colleagues there. So I went in a few days before the conference, before SANOC conference, to try and understand what was causing this problem. So got myself a local SIM, 4G enabled. I get my V6 prefix, very happy. I go home, meet my folks. Next day morning, I don't have V6 prefix on my phone. Right? That was very weird, but I had no explanation why V6 prefix wasn't there on my phone. It was there yesterday. Again, I had to toggle the airplane mode, basically reset the connection. I get my V6 prefix back. But then Jiten Tinle, who is the CTO of Bhutan Telecom, he SMS'd me saying if I could come and inspect the venue for SANOC 33, check if the workshop rooms are okay. He sent me a SMS, and then I lose my V6 prefix. Again, I toggle, I get my V6 prefix back. And then when someone calls me again, I lose my V6 prefix. Right? That's when I found out that because Bhutan Telecom, Bhutan being a very small country, there's not many internet users there. So what was happening, instead of doing voice over LTE, they actually fall back to 3G for SMS and calls. Right? Voice over LTE was too expensive for Bhutan Telecom. So it was very weird that whenever there was fallback to 3G, I kept losing my V6 prefix. So probably that was what was, no, there is a nice story to that, Jordi. I know you're shaking your head. Shouldn't be happening, but it happened, right? It happened, and I was there to observe that. So after reporting this problem, met with the mobile team in Bhutan Telecom, and then the fix wasn't really difficult. Initially, convincing them was very difficult, that there was a problem in their network, so I had to prove it on their own handset, right? They said, maybe it's your handset. I said, let's try on your handset. Right? Call that number, V6 prefix gone. SMS that number, V6 prefix gone. So kind of proof that I wasn't lying, right? And it wasn't just us, and this is perfectly in sync with what APNIC's measurement tool saw, because APNIC relies on Google's ad network for the measurement, right? And Google also saw Bhutan's capability only about 5%, right? But after the fix, this is what I took about before I was here a week ago for the IPv6 deployment workshop. I wanted to share this with the class. So you see now it's over 16% from 5% after the fix. Right? And the fix was very quick. They were convinced, they went ahead, they found out the V6 profile was missing on 3G, they enabled it back, and then since then, that the V6 capability of Bhutan is sitting above 16%. Right? So that was what me as a user troubleshooting or fixing a V6 connectivity issue in Bhutan. And then a few days later, I was also teaching V6 deployment workshop at Sanok 33 with Philip. And when I mentioned this to the class, there was one guy from Sri Lanka, Dialogue, right? He said, hey, Tashi, even Sri Lanka's graph seems to show something similar. What do you think? Right? You can see pretty much around the same time, November, they also had this from something that was above 15%, they also had gone down below 7% capability, right? Then I was asking him, what happened sometimes in December? What did you guys do in December? Then they said, we deployed voice over LTE. So there you go. Even they had similar problems. So it turns out it wasn't an isolated case for just Bhutan Telecom. And trying to dig a bit deeper, turns out it could possibly be caused by Ericsson's CERT root CA problem. Because when they had to, most of the operators who were running Ericsson's mobile core had to roll back to an older version. And when they rolled back, probably the V6 profile on the 3G got removed and the engineers never checked. Right? So as you can see, so that is the story that I wanted to share since this is a V6 deployment session. I hope it's interesting enough, Jody. Now, I hope you're convinced, right? And this is not because Jody is in the room, right? This is just what we are seeing in the region because we travel a lot in the region. What we are seeing is there is no one particular transition technique that people are picking, right? It depends on their own thinking. It depends on what they have in their network, the kind of assessment that they do. And like Chungwa Telecom just mentioned, they have a massive research and development lab, yet they decided to do dual stack. So what we are seeing is in the last 3 or 4 years, some of the major operators who have, by major, I don't think Bhutan Telecom is major, but it's major in that country, so that's the definition of major, right? So what we are seeing is dual stack. You look at Reliance Jio, dual stack, massive mobile operator in India. AI is in Thailand, dual stack. Bhutan Telecom dual stack, and the latest one being Chungwa Telecom, again dual stack. This is just sharing with the crowd here the trend that we observe, right? And before I conclude, APNIC, we do provide a lot of trainings. We do provide technical assistance where possible. We have a one-stop shop sort of thing on our website, apnic.net/IPv6. The deployment part is very interesting because there are, we coordinate and collaborate with industry experts and get deployment planning, based on their experience. If you want to deploy V6, what are the basic steps that you need to go through, right? So that's the deployment planning stage. We have success stories of not only mobile operators who have deployed V6 within the region, but we also have content providers like LinkedIn sharing their stories about how they deployed V6 in their network, right? So those of you who plan to deploy V6 in your network, please have a look at this page. It might be useful to you. Thank you.
Thank you, Tashi. Any question? Okay, thank you. Okay, next speaker will be Judy Pellet. He's going to introduce IPv6 deployment in IoT. Thank you.
I have the slides here? Yeah, okay. Okay, so my original plan, or what I was asked for, was to talk about a specific IoT deployment with IPv6, and I am working in a big project. Unfortunately, the customer didn't authorize me to disclose any information, so I could not do that. So I figured out, okay, maybe what we want to have is a summary of what is the relation of IPv6 with IoT, because I guess that most of the people here don't follow IETF and all the working groups relevant to IPv6 and IoT. So that's what I am doing here. It seems very simple, but actually it's really, really, really complex. So this is the full and incomplete picture of all the relations at different layers between IPv6 and IoT. So of course we have the layer of link, the physical media. We have on one side, ITF, which are the related standards, and then we have a lot of organizations like ISO, IAC, W3 Consortium, etc., which also do a lot of things related to standards close to IoT or related to IoT. And then we have industrial partnerships or organizations like IPSO and a few others. Just to mention a few, I don't want to go through all the details of the slide. And many other industrial consortiums also working the same. So really, it looks like something very simple, but it's not at all. And I am going to concentrate mainly only in the ITF part, which as well is not really just a couple of working groups. So obviously what is the relation between IPv6 and IoT? Huge number of devices, things like auto-configuration, header compression, IPv6 only. Dual stack in many cases is not an option because tiny devices. And I asked to the first speaker actually, why do you think that IPv6 is a big extra? Well, what is a big extra is having both protocols, especially because if in the long term you are going to have just IPv6, the cost in terms of a stack can be actually smaller, right? But not really that much. So even if I have that in the slide, it's not really that much significant. There are stacks today that have less than 200, 250 kilobytes. So this is really very condensed already. And also the other reason for ITF to start working on a specific protocol for using IPv6 on IoT was going away from standards which are sometimes from specific vendors like Zigbee and a few others, Sigwave and others, right? So that's a little bit the history why ITF decided to step in on this, in addition to making sure that it's IPv6. So the first working group that started working in IoT was called 6LowPAN. 6LowPAN stands for IPv6 over low power wireless personal area networks. It was based on the same media that Zigbee, which is 802.15.4. And well, you have here a picture about what part of the protocol stack is being covered by IEEE and which part is ITF, and then you have on top of that the applications. Okay, so that's a very simplistic definition of what is exactly doing this working group. Okay, so what challenges got this working group? First, small packets, which means taking care of fragmentation, header compression. One interesting thing that most of the people don't know is that it's much easier to compress or to compress more, let's say, IPv6 than trying to do the same with IPv4. So that's quite interesting because, of course, the IPv6 packets or headers are bigger than IPv4, but on the other way, they are more compressible. Neighbor discovery, which is one of the key things in IPv6, is not that much efficient in low power wireless. So this working group needed to attack that problem, right? Another important thing is that in IoT networks, you need to support both type of topologies, star and mesh. So it was a very interesting problem to solve as well. And of course, security, privacy. In computers, in laptops or cellular phones, you don't have that problem because you have a very powerful CPU and you don't care if you need to run very complex protocols, encryption, etc., etc. But in very small devices, very cheap, with very low power consumption, you cannot do that. So it's really complex to do that or to keep doing that security and privacy in those nodes. The other thing is, in terms of energy conservation, it's very important that nodes that are just reporting data from time to time can go to sleep. So if you are using neighbor discovery and similar protocols which are based on multicast, you cannot do that. Okay, so those are, again, the challenges that this working group tackled to make sure that we can run IPv6 on top of IoT technologies. So this working group 6LowPan already finished. I think it was something like 3 or 4 years ago. No, I'm not sure exactly, but more or less. And then we started work in another working group, which is 6Low, which stands for IPv6 over networks of resource constrained nodes. So it's basically extending the work of 6LowPan, taking care of ND neighbor discovery extensions that can work in this kind of networks, taking care of the privacy issues that were not solved in the previous round, let's say, and looking into making sure that we can use these protocols, 6LowPan, on top of many other physical media like Bluetooth, DECT, G3 PLC, and many, many others, okay? And in general, keeping it open for future physical media, being sure that can be adopted the same protocols as well. Then we have also another way to transmit information, which is TSCH, which stands for time-slotted channel hopping. And this was introduced in 2012, so we needed to create also recently a new working group, which is 6TSCH, to make sure that we can still keep going with this technology. So this is a totally different way of doing IoT in the sense of the user cases that is approaching. So it's not just low power, but also loosey networks, typically industrial networks, things like that, which really, really require deterministic behavior. Okay, so that's the basic difference with the previous work. Oops. Role basically is making sure that we can also do kind of routing on IoT. Okay, so very, very short definition is we want to make sure that we can have mesh networks in IoT and we can do not just layer 2, but also layer 3. That's basically what this working group is doing. Core is constrained or means constrained RESTful environments, and basically is the working group that took care for defining what we call the CoAP, which is Constrained Application Protocol. So it's the way very, very close, let's say, to what we do with HTTP to transmit information in a network of sensors, but making sure that is more efficient, faster, and consequently has less and less power consumption. That's basically what it means. Typical expectation is if we can get in a single cell battery maybe 5 years, or I mean cell button battery. You say button battery in English, I am not really sure. Make sure that it can last 5 years, 10 years, because you don't want to replace the batteries every year or something like that. We are talking about millions of devices, right? DICE. This is basically DTLS. There was an interesting presentation this morning about security with DNS. So this is DTLS in constrained environments. Okay, so making sure that we have the same security in this kind of IoT environments. ACE. Authentication and authorization for constrained environments. I think it's saying all. It's basically making sure that you can know and you can allow only those devices or those nodes to do access to the relevant part of the network or the relevant data and so on. So it's basically like a kind of triple A for IoT. Let's call it that way to make it simple. LP1, IPv6 over low power wide area networks. Well, again, I think there have been a couple of presentations this week here about LoRa. And LoRa is one of the possible technologies, but we have also Sigfox, Wi-SUN, NB, IoT. And basically what these technologies are trying to do is kind of optimization of the radio modulation to make sure that even if we need to transmit at very, very long distance, but very few bits or kilobits or kilobytes, but we make as much efficient usage of the bandwidth, right? So it has some additional implications in terms of very low speeds, variable MTUs. So it has some different constraints that what we have been using in today's network technology. So it's also a challenge, and there is a lot of work being done in ITF on that as well. Lightweight implementation guidance. Well, this is basically trying to help implementers, because one of the constraints of IoT is nodes have very limited memory. We are talking about RAM, flash. So how you actually try to help people developing IoT devices to make it as much efficient as possible with the smaller code they can build. Okay, so that's the basic idea of this working group. Suite. One of the problems that we have with IoT, and again it was mentioned I think this morning in another presentation, is what happens if we get it wrong, if the firmware is broken. It's necessary to replace the devices. The devices can be very cheap, but we are talking of millions of them. And what about the human resources to replace them? So no way. We really need to make sure that we provide a way to do secure firmware updates. And there are different classes of devices defined in one of the documents. I mentioned those in the slide, but just to give you an idea, typically, if you have, for example, a flash of 100 kilobits, you will not have code which is taking more than half of that flash. Because if the upgrade fails, you want to make sure that the device is still able to fall back to the previous firmware. So that means that even if we say here the code size is 100 or 250 or whatever, you can only use half of that. Okay, so that's extremely important. Web of Things. Now, we have all the protocols, all the base protocols. That's what I have described in the previous working groups. Do we want to make sure that different vendors, different kind of sensors, different kind of devices can talk together by means of common semantic? So that's what the Web of Things is trying to do, making sure that if you have a sensor from one vendor, for example, a temperature sensor from one vendor or from another vendor, both of them can talk the same language. Okay, so that's kind of interoperability by means of semantic. And there are a lot of protocols that make that possible as well. This will be the overall diagram of this Web of Things. Okay, so we have the hardware network, the physical interfaces. We have 6LoWPAN, we have IPv4, IPv6. Of course, if we have 6LoWPAN, there is not support for IPv4, but it may be in other layers. We have co-op, which is equivalent to HTTP somehow for IoT. And then we have APIs and services like OMA, web servers, and then data models like IPSO, and then the applications on top of that, which we call hypermedia web applications. So this is the stack of protocols, and as you can see, some of them belong to IEEE, some others to ITF, some others to other organizations. So it's, if you remember my first slide, it's really, really complex picture and is not really complete yet, okay? And finally, and I think is my last slide, there is an interesting, in my opinion, this is my personal opinion, but I think I am not too much wrong. There is an interesting consortium of vendors, companies like Google, Apple, and many others are involved on this. So if you look at the weight in the industry of those vendors, it makes sense. Call it Fruit Group. And this is basically looking at the full picture, and it's only based in IPv6 and making sure that we can have a viable model for consumers to take advantage of EOT, basically, okay? So there is probably some more details in my slide, but the final rationale is we want to make sure that consumers can take advantage, for example, for security in their homes, for home automation, many, many other similar aspects, and not just the industry. So also consumers can make an easy use of EOT, which IPv6, in their homes. That's the basic thing. And that's it. I'm not sure if I want too fast or, but whatever, it's okay. More time for discussion.
Okay, thanks, Jody. You force us to read computer dictionary. Any question? No more questions, thank you.
We are here all the week, so questions in the corridors are welcome as well.
Okay, thank you. So next speaker will be JiaBin Huang from APNIC. He is going to introduce IPv6 deployment in Taiwan. Thank you.
Good evening, everyone. I'm JiaBin Huang from APNIC. My presentation topic is about Taiwan IPv6 deployment. This outlines the first part is the status for the outcome of the criterion of IPv6 measurement. The second part is the status of IPv6 deployment in Taiwan, including the main ISPs, government network, and the academic network. The last part is the conclusions. The first measurement criteria is the IPv6 BGP advertisement. The ratio of the IPv6 BGP advertisement in December 2018 has arrived at 44%. This number is not gross last year. And the second measurement criteria is the IPv6 service availability. The data collection from the ALISA top 1 million websites. The ratio of IPv6 service availability in January 2019 has arrived at 10%. This number is also not gross last year. And the third measurement criteria is the IPv6 the user availability. The ratio of the IPv6 user availability in February 2019 is around 30%. This number is goes from less than 1% to 30%. So this number is grows a lot last year. The contribution for this IPv6 usability is include major ISP have a lot of contributions. The first contribution is by the Chunghwa Telecom. Chunghwa Telecom Mobile has arrived at 75% last year. It's also from the less than 1% to the 75%. in last year. So it grows a lot. And because it default provide the IPv6 services to their customers. The second ISP, the Far Eastern network, he also arrived at the 51%. This also grows from the less than 1% to 51%. The third is the Taiwan Mobile Telecom. He arrived the 30% right now, and he is also from the less than 1% to 30%. Besides these three mobile telecom, the Zhonghua HiNet is also has a lot of contribution. It's about more than 20% in usability. Besides ISP, the government network has arrived at 8% right now. It's from less than 5% to the current 8%. Another part is the academic network. The usability in Tarnet has arrived at 23%. It's from the less than 15% to 23%. So the conclusion, the ratio of the measurement criteria IPv6 location and the BGP advertisement and service availability steadily grows up in Taiwan. And besides, the Taiwan IPv6 usability grows rapidly in last year. It's all my presentation. Thank you very much.
Okay, thank you. Any question?
Hi, Tashi from APNIC. First of all, congratulations. That's a very good jump from nothing to 30% for the whole country.
Thank you.
You showed every measurement. It would have been nice to also see V6 traffic across internet exchanges in Taiwan. That would have given a nice picture of how much of the V6 traffic is actually local or domestic traffic. So maybe that's something you would want to do, or maybe you already have plans to do that.
Yeah, regarding to IPv6 traffic, basically it's very confidential information from service provider. And if we try to tap in the traffic information, that would be claimed as a law infringement.
Wouldn't the IXPs have looking glasses? Wouldn't they be not looking glasses? Wouldn't they be showing their traffic over the IXP published on their website anyway? So that shouldn't necessarily be, not saying the flows, right? I'm just saying what's the volume of IPv6 traffic over internet exchanges in Taiwan? Just that's that.
Yeah, thank you. I think we can, as a TWNIC, we can coordinate to see what sort of information they're willing to share to public. I think something we can do. Public with a very limited information will be helpful to the public. And we have the board member from Zhonghua Telecom willing to contribute. Go ahead.
Well, that answer should be very simple and short. If you go to the Alexa to take a look about the top 500, the website in every country, only one country is different, exceptional, is China. The rest of the country, if you look at the top 10, almost all of them is Google, Facebook, YouTube, Microsoft, Amazon, something like that. And those of that, if you look carefully, those are American big internet company. They almost attack 60% to 70% of the traffic in every country. And those of the website, the company already have a V6 ready. So if you want to make the IPv6 flying, It's very simple. You're just asking the telco, turn on the mobile into the V6 mode, then done. Now the next step is the most difficult part. How can make your local content provider to turn on the V6? Because the local provider, usually they don't know how to do it. So I think that's the next step we need to do. So if you look at that, I can just give you a very simple one. Basically in Taiwan right now, like Zhonghua Telco, I cannot give you the detailed information, but basically the V6 traffic is about 30%. Yeah, because it's simple, because your mobile to those of a major American ICP done. Yeah.
Okay, thank you. Any other question? Okay, no question. Thank you.
Yeah, thank you very much.
So our session is almost complete. Before we end this section, can we give a big hand to all speakers today, this afternoon? Thank you. Okay, thank you for all your participation. Thank you. I think the session is complete right now. Thank you.